All right, so while we're opening to page 61, hopefully everybody has their test back. The mean and median are over here on the whiteboard. Median was 75, mean was right around there at 77. Highest grade was again 100. Yeah. So so it's okay. The material on the last two quizzes is certainly tougher than the material on the first two quizzes. So I'm not at all surprised that the mean and median are down in the mid and high 70s compared to they were higher before on the earlier quizzes. Yeah, same kind of thing with the other person that I'm kind of teaching this class with. So let's take a quick look at the calendar. We just had quest number 4 right there. Today we talk about problem solving, that is to say some more word problems. Next class, Wednesday coming up, is our review day for the tests. Friday is the test. The only difference between the test and the quest is that the test is on everything since the first test. The quest was only on a couple of sections. So to be clear, the material covered on the test, Friday, is classes 19 to 34. And class 19 to 34 is starts right there, right after the last test, right? There are practice problems in the packet, absolutely. Yeah. So test number 2, we have only 2 tests the whole year and then the final exam. So this is test 2 and it's coming up on Friday. Yeah, final exams on everything. Okay, so again, the plan, we have one more day of material to do today. Wednesday is our full period review. Friday is test number 2, okay? Yeah. All right. Right. Okay. And just while we're thinking of Jenny's question about the sample test problems, can somebody maybe try to find these? I'm guessing that, here we go, page 65. Go to page 65. Everybody see the practice problems for test number 2 on page 65? Yes. And again, there's an answer key that follows. There's a PDF of my solutions, the color solutions up on Moodle, and there are videos on YouTube of me going through all of these problems. Okay. So you have resources, just a matter of finding the time to take advantage of them. Okay, so let's do this stuff here in the middle of page 61. Can we start with Katrina on number 1? So looking at our parabola here, does this parabola have a minimum or a maximum? Has a minimum, right? Right down there on the bottom. That point is lower than any other point on the graph. It has no maximum. It goes up forever in both directions. But what is the name of that minimum point on this parabola? That's the vertex. And if it were a sad parabola, what would the name be of the maximum point? Also the vertex. So today is really about finding the vertex because we're going to be finding where a thing is minimized or where a thing is maximized. Let's go to number 2. Dan. Okay, so we've seen this parabola a couple of times. Joe? Okay, I think we've done this as well. Go ahead and write down coordinates. Remember, 2 coordinates for every point. So find any x-intercepts you can on this graph and then estimate the coordinates. If you're on the x-axis, is the x-coordinate 0 or is the y-coordinate 0? The y is 0. So at something comma 0, what's the left x-intercept? -6, and the right one, 1. 1 comma 0. Okay, and then we can find we can estimate the coordinates of the vertex. This is the next part. So we're just trying to ballpark what the coordinates are of that point right there. Yeah, maybe -2.5. It's hard to know exactly, but we can estimate -2.5. And then other thoughts on what the y might be there? -12. -12.5. We don't know. We're just ballparking. estimate, okay? All right, now we're going to find these answers exactly, meaning we don't have to rely on the picture, because as soon as you rely on the picture, you are estimating. So we're going to find all these answers exactly, and all that we need to know is the equation of the curve. It's there. So if we want to find the x-intercepts exactly, what can you say about any point on the x-axis? The y is 0. So then we can take that blue circled equation and instead of y, put 0. So we're going to solve this equation, which I think we've done before. Yeah. Now solving that equation is something that you did on the quest many times. You solved equations like this. So first of all, is it good or bad that there's a 0? That's very good. That's usually the first step for quadratic equations. Now, I will say this. Some of you are very enamored with the quadratic formula. And I say that because some of you refused to try factoring to solve any equation and just did the quadratic formula every single time. And I don't think that's the best strategy, because quadratic formula is very big and it's very messy and it's quite easy to make arithmetic mistakes in there. You know the b squared minus 4ac part? So if a is a negative, then that's like a subtract and then there's a negative, and several people missed the fact that that turned into a plus. I think it's really easy to make mistakes using the quadratic formula. If the thing factors, it is generally a much better technique to try factoring it. So this one factors. X. Don't forget the 0 equals. It's still there. Where does the P go for the PS? The P is above the -6. The S is the 5. And so we'll just make our quick table over here. Looking for two numbers whose product is -6. Okay, so I'm going to do, I'll do -6 and +1 first, just so we don't grab the right answer on the first one. Any other possibilities for a -6? Okay, it could be -1 and +6. Any other choices? -2 and 3 is good. -3 and 2 is good. That's it. There are no other possibilities, and you just churn through them. Those are my choices there. Over here, we're going to do the sum. -6 plus 1, -5. I wanted +5. -2 plus 3, 1. No good. -1 plus 6, 5. That's the winner. -3 plus 2, -1. And as soon as you see the winner, you just grab that and throw it into your kind of skeleton here. -1, +6. Yes? And then don't forget, we're splitting this into two equations. Either x minus 1 is what number? 0, or x plus 6 is 0. So x equals 1, x equals -6. Any questions on that? And with practice, factoring can become almost second nature. And if you can factor, it is always better to do that than the quadratic formula. Yes, which is why it was a little bit frustrating to see so many quadratic formulas. Yeah. Yeah, and I definitely said you can use the quadratic formula to solve every quadratic equation, and some of you took that to heart. Okay, so those are the x-intercepts. Do they agree with our estimates from the graph? -6, 1. Same numbers, so we read the graph correctly. That's great. Now we're going to come down here and find the x-coordinate of the vertex. We estimated it before, but now we can find it exactly. We know definitely that vertex is perfectly in between the two x-intercepts, yes? That vertex is right smack dab in the middle. So what do you have to do with -6 and 1 to figure out where the vertex is? Average them, right? Add and divide by 2. So it says let's find the x-coordinate by averaging the answers we got in part C. So this is easy enough to do. The x-coordinate of the vertex is definitely equal to the average of those two numbers. 1 plus -6 divided by 2. Did we get it right when we estimated the vertex? We did. But if it had been -2.6, I would never get that right. But this will always work, right? If we average the two numbers, it's the perfect answer, which is oftentimes better than the answer you get by reading the graph. Okay, so this is all review stuff. Any questions on any of that? So if we're ready, we go to the next page. And I think we're around to Glenn. No, sorry, Sebastian in the back. And that would be pretty rough, wouldn't it? Like suppose you couldn't factor, and so the x-intercepts that you got were like -1 plus or minus square root of 7 divided by 4, right? That's a typical looking answer when you use the quadratic formula. And so what you have to do is average those two numbers, -1 plus root 7 over 4, and -1 minus root 7 divided by 4. And to average two numbers means, what do you do with them, Jenny? Yeah, I said it before. Yes, add and then divide by 2, which would be quite kind of horrifying to have to do that to these two numbers, right? Okay, let's keep going here. It gets worse. Michelle? Yeah, so what if your parabola doesn't hit the x-axis at all? What if it just does like this? Does it have a vertex? Yes, it does. Every parabola has a vertex. Does it have x-intercepts? No. So our technique of averaging these two numbers to find the middle isn't going to work. There's no two numbers that I can average here. Okay, so let's go to number 4, which will solve all of these problems. Jenny. Okay, thank you. We'll go to Ben for the, it's right below number 4, for the.
Quadratic equation y equals ax squared plus bx plus c. The x-coordinate of the vertex is given vertex 1. X equals a to b.
Okay, there you go. Most important formula of the day. The x-coordinate of the vertex happens at -b over 2a. Let's see that formula in action before we move on. The equation that we just looked at from the previous page, x squared plus 5x minus 6, right? Did I get that right? Okay, now let's find the vertex using this fancy new formula. X equals -b divided by 2a. Let's try it. So I'm going to write x sub v. It's the x-coordinate of the vertex. That's what the v is supposed to stand for. So the formula is always -b divided by 2a. So you do the opposite of b. How much is b? 5. So we do the opposite. -5 divided by 2 times a. A is 1. Everybody see where these things came from? And it's the same calculation we did before. We didn't realize it before, but I mean, it's the same -2.5 that we got before. Thank you. All right, that's what we got. Which way is easier to get this number? Let's go back. So one way is to solve this equation, which means factor it if possible, quadratic formula if not, get two numbers, and then what do we do with those two numbers? Average them. That's one way to find the answer of -2.5. The other way is to plug into this magical formula, -b over 2a, and you're done. It's kind of nice. And it also works if the numbers are messy. You don't have to average two messy numbers. You can just use this. And it also works if there are no x-intercepts, like in the red parabola at the bottom here. Yeah, x equals -b over 2a. So let's use it. Oh, the other thing is, I will tell you, you kind of know this formula already. That should look familiar. Yeah, this is part of the much bigger quadratic formula, right? Negative b plus or minus square root b squared minus 4ac, all divided by 2a. That's the quadratic formula, ignoring everything after ignoring the plus minus and everything beyond, right? It's negative b divided by 2a. So you've already, if you have the quadratic formula, you already have this. You just have to circle it. It's right in the front of the quadratic formula. Okay, so let's try number 5. Melanie. Okay, x sub b equals. So write down the formula, see if you remember it. If you don't remember it, we can look up, but it's got a fraction line. What goes upstairs? Negative b divided by 2a. That's the fancy formula. Then we plug in. Yeah, so I'm going to write negative 4 just to be detailed, divided by 2. What's a? Still 1. 4 divided by 2, 2. Any questions on finding the x-coordinate of the vertex? It's easy, right? Yeah. Okay, but technically a vertex is a point. And how many coordinates does a single point have? Has 2. This is just the x. So here's a connection that some people lost a little bit during the test. They knew how to find the x-coordinate, but then weren't sure where to go to find the y. Where do you go? There. That's the equation that tells you if you know what x is, just plug into me and you will figure out what y is. So what number are we putting in for x? Is the 2. So just plug x equals 2. Plug x equals 2 into the original. So it says y equals, I'm going to put, every place I see an x, I'm going to just put blank parentheses. And every one of those x's becomes 2. I get 3. Okay, and so then putting both pieces together, what are the coordinates, both numbers, of the vertex? X turned out to be 2, y turned out to be 3. And so you find them completely separately, right? You find the x by using our fancy new formula, negative b over 2a. You find the y by plugging whatever you just got into the original equation. Any questions on that one? Okay, let's go to 6. Glenn. Okay, so to decide if you have a max or a min, you just need to decide if your parabola is happy or sad, right? That completely determines whether you're looking at a max or a min. This one's happy because the x squared is positive, right? That x squared term is a positive 1 in the front, so it's a happy parabola. The happy parabolas have a max or a min. They have a min. So we can write that. The a in this problem is what number? Is 1, which is definitely positive. So we'll just say is positive. So the parabola looks like this. So that point right there is a min. Questions on that? Okay, so that's all the theoretical stuff about the vertex. Now that we know how to find the vertex, given a formula, we're going to introduce words into these problems. But the important thing is here, once we get past the words, We're just going to be looking at a parabola in some context. And so if we can get to that equation, if we just have the equation of a parabola, the word shouldn't be frightening. Finding the vertex of a parabola is very easy. We just did it. So let's start here with 7. Adam? Okay, subtab number 7. Go ahead. Okay, so looking at that equation right there, I'm just going to translate it into x's and y's. Which one of these is my x? It's the t, because I'm used to seeing x squared. So okay, so it must be something like negative 16x squared plus 12x. T is just x, which I guess means the h must be playing the role of y. Okay, so now it looks quite familiar to me, x's and y's. And it is a parabola because of that x squared. Happy or sad? Sad, because of the negative. So I've got some downward parabola, which I will draw. That's what this parabola looks like. Really not paying any attention to the numbers. I don't care about the 16 or the 12. I'm just drawing some generic down parabola. And that parabola, again, is supposed to indicate that the ball is going up, and then it reaches the top, and then it comes back down. And it has a maximum, yes? And what math word tells you where to look for the maximum? What's the name of that point? It's the vertex. So this problem, even though it's, it's got words around it, it's got height and time and rock, this problem is really just asking you to find what? The vertex. So once we translate, say, oh, maximum height, it's vertex. Now we used our vertex process. So this really just means find the vertex. Okay, so let's write our vertex formula. Again, it's got a fraction. See if you can remember it just from memory. It's got A's and B's in it. Write down the vertex formula. Don't put numbers, just A's and B's right now. Okay, somebody we haven't heard from yet. What's on top? Negative B. On the bottom, 2A. I'm going to put one more letter in here. It's the one in the front. Most people don't pay attention to it, but what are we finding? Is the x, right? This is an equation. It's not just negative b over 2a. If you put the x, you will remind yourself you are just finding the x coordinate. You're not finding the entire vertex, which has an x and a y. You're just finding the x. But then I'm going to change it because we don't have x in this problem. What problem do we have? Or what letter do we have? Is it h or t? Which one is the x? It's the t. So this must be finding me the t. And that's really important because we're about to get a number. And that number is going to tell us something about the vertex, but we need to be clear. Is it telling me the t at the vertex or is it telling me the h at the vertex? It's the t, right? So you just really have to do this translation idea. The t's are playing the roles of the x's. It's like an understudy at a play, right? So the t's are the x's. So as long as you have this x as part of your formula, you just replace it and say, oh, x is really t in this problem. I'm about to find the t. I'm going to find the time when the rock is up there at the top. Okay, so we plug in negative b, negative 12, divided by 2 times a, negative 16. Not that it matters, but how much is c in this problem? 0. And the c makes no difference as far as the vertex is concerned. It's kind of surprising, but the c doesn't matter at all. So let's see, that's a negative 12 divided by negative 32. And we can reduce this if we want to. Certainly you should at the very least make them both positive, but we can reduce, right? 4 goes into both of these numbers. 3/8 is good. And 3/8 of a second is okay, but probably decimals is more appropriate for time. So you can type that in the calculator, or maybe you happen to know what it is. The 2 negatives canceled to make a positive. They were both negatives. Okay, so that 0.375, it was measuring t. time. Is it telling me something about where my units? Well, I didn't tell you what the units were, did I? Oh, I did, yeah. Here are the two units, feet and seconds. Which one is this? This is, well, it's one of them, feet or seconds. This is T, it's seconds. Right? T is what we found, it's time. It takes this rock 0.375 seconds to go up. It reaches its maximum at 0.375 seconds, and then what happens? Then it comes down. It's going to take another 0.375 seconds to come down. That's neither here nor there. 0.375 seconds is how long it takes for the rock to get up to the max height. How do we find the maximum height? Yeah, what we just figured out right here is that the T is 0.375. We want to know what the H is, but H is really what letter for us? H is really the Y, and how do you find the Y? You just plug the X into the original. So that 0.375 is just getting stuffed into this original H equation. Katrina? What are my what? Not the answers to this problem, apparently. Did we do something wrong? Negative b divided by 2a. 12 or 32, that's it. So apparently those are the answers to a different problem. You guys are spoiled. Yeah, you gotta, it's like Jeopardy. I tell you the answer and you figure out what the question was. So we can cross that off. That's not the answer to this question. But we can find the value of what? Of h. So I'll write the formula from up above. It was negative 16 t squared plus 12t. That's the h formula. Every one of these t's, I'm just going to replace with parentheses. And then what goes in those parentheses is a 0.375. This would be impressive if I could do this, right? Uh, 2.25? I definitely did not hear you. 2.25. Cool. Oh, okay. So so doing this on the calculator, let's see if, yeah, it should be positive. Yeah, so I'm not going to try this. .375 squared plus 12 times 0.375. Yeah. Okay, any questions on this one? Yeah, so that right there is a height. The height in this problem is measured in feet. It would be good to just write one final sentence telling the reader exactly what these two numbers represent. So just write down a sentence. Your sentence is going to have 0.375 seconds. You're going to write that word, and 2.25 feet. Just write a sentence. Probably should have the word rock in it as well. And as you write the sentence, I will say there is one other word that needs to get into the sentence. Without this word, you will not get full credit for your sentence. It is maximum. The maximum, yeah. So I'll write down a sentence which is correct, but not full credit. The rock gets up to 2.25 feet after 0.375 seconds. Is that true? Not true? Yeah. It's true. It's not a full credit answer. The rock reaches a lot of heights at a lot of different times, right? You could write another sentence here about where the rock is after 1 second, right? There's a lot of true sentences you can write about this rock. This is a very special point. This is a really special point that we just found. It wasn't just any point, it was the vertex. It's the maximum. So how about we make this a full credit answer, gets up to a maximum height. That is a full credit answer. If you don't have the word maximum in here, you're missing the boat about what you found. There are many points on this parabola. You are finding a very special one. Any questions on that? Okay, next page. Number 8. Where are we now? Teresa. Okay, so let's take a look at this picture. We've got a fence that we're gonna spread around here, and we don't have to put a fence along the river. Apparently, whatever animal we are corralling doesn't like the water. So you could make a really, so you have a certain amount of fence. So you could make like a really long but narrow corral, right? Probably the animals wouldn't really pass each other. They could just, they'd run into each other and then go back the other way. That's one option. You could make like a really tall kind of thing, but then what's the problem? It's going to have to be kind of narrow there. You have only however much fence you have, 400 feet. And you could do everything in between, right? There are a lot, these are kind of two of the extreme cases, or you could do what's pictured here, which is maybe like a blend of those two. But what could you say about the area of like this guy? Would you say that's a big area or a small area? It's pretty small. Compared to the area of the one that's drawn in your picture, this looks like a lot more space than the picture that I drew, right? So of all these different ways we could build our fence, we want to find the way to make the area of the fence as large as possible. Here is the phrase, largest area. And what do you see? What math thing do you see when it says largest? What does that really mean we're finding? It is a maximum. We are finding the vertex. That's what it says. It doesn't say it, but that's what we interpret it as. This is a find the vertex problem. I don't know that we have a parabola yet. I'm assuming we're going to get a parabola from someplace, but if it says find the biggest something can be, the only things we study this year are lines and parabolas have maxes. So this must be another one of these find the vertex. Okay, so here we go. The hard part of this problem is not finding the vertex. The hard part is finding the formula for the parabola. So I've already gotten you started here with some variables. X is going to represent the width of my fence. I have a total of 400. Can you guys figure out how long this is? It's going to have X in it. 2X is related to the answer. 2X is how much fence you've already used on the right and left. So I don't want to introduce another variable. You could just call it Y, but I'm trying to avoid a second letter. Okay, let's just introduce. Yeah, it is 400 minus 2x. So if you see that, then super. But if not, we can introduce another variable and get that. But let's see if we buy this. You have 2x that you've already used, right? But you have a total of 400. So whatever's left over must be available to you at the top. 400 minus whatever you'd used. So that's good. There's a lot of work going into finding that. Yeah. Oh, I meant the length of the line. Yeah, I was looking for the length of the line. So alternative, what is the perimeter with these letters? Okay, everybody buy 2x plus y. That's how much fence we've used. But we have 400 feet available to us. So it must equal 400. And the goal is to figure out what y is. So what do I do to solve for y? I can subtract the 2x. So this tells me that y is equal to 400 subtract the 2x, right? So if you can just see that it's 400 minus 2x, that's great. But if you can't see it, call it y. But then right away, you know, you're not allowed to have a second letter in here, so you better find some way to get rid of it. Okay. We are trying to find the largest area. The keyword here is area. Apparently that's the formula that we're after right now. Area equals length times width. You could just write it in terms of just any old generic rectangle, and then we'll trade in for the specifics that we have on this rectangle. The length, 400 minus 2x. Width, what is the width? Is it 2x? So the width is this, or the width is this, right? Just x. The width is just how long this line is. That's x. Well, it's going to become whatever we get when we FOIL this or when we distribute here. But x squared doesn't pop into this until it's sort of natural to do so. All we're writing was the length and the width. The length is the length of this line, which is just 400 minus 2x. The width is the length of that one. It's just x. And we're multiplying those two things together. Okay. So now let's go ahead and distribute this just so it looks like a normal looking parabola, like a standard form parabola for us. So 400x minus 2x squared. And that still doesn't look like standard form to me because I always have my x squared first. So 2x squared, and then 400x, and then we got to put the right things in the spaces. Yeah, that 2x squared was negative the whole time, and it's a positive 400. So just be careful with your signs when you rearrange. That's the formula for the area. It is a parabola. Does it open up or down? It's negative, so it opens down. So does it have a max or a min? It has a max. Max is what we are asked for, the largest area. So I want you guys to now find two things. Find the x coordinate of the vertex, and then find the y coordinate of the vertex. See if you can check in with your neighbors as you go. Okay, so just bringing everybody back to the same place. When we do our big calculation here, we get the x coordinate of the vertex is how much? Yeah, just the final answer. That was 100. Okay, so the x coordinate of the vertex is 100. If you want to find the other coordinate of the vertex, usually it's called y, but y is the worst letter to name it in this problem because y actually was a letter that we randomly picked and put it there. The letter that we have here is not y, it's a. Right? Normally our parabola is y equals x squared, right? So we have an a standing in for the y. This is where we go to find the other coordinate of the vertex. So when you plug in 100 in for those x's, turns out the area is 20,000. So the x is 100, the a is 20,000. And the other thing that we should find, we already know x is 100, but probably we should be able to figure out this length. We know that x is 100, so plug x equals 100 right there. That will tell you the length of this rectangle. Yeah, 400 minus 2 times 100. So if we plug in x equals 100 here, we get y is equal to 400 minus 200, which is just 200. Any questions on this? So putting it all together, there's it's all written up in one nice little sentence here at the bottom. 100 feet by 200 feet, that's the X and the Y, encloses the maximum area of 20,000 square feet. Okay, let's take a look at one where we're given a formula, but the formula here is going to be kind of messy. It comes from a model. Number 9, Tenzin. Thank you. Okay, so let's see if we can get a handle on what that crazy looking formula is telling me. So the first thing I'm going to do is just plug in x equals 0, just to try to get a start on it. And when I plug x equals 0 for both x's, then all the x terms become what? 0. So the final answer is just 50.604. Okay, let's write a tiny little sentence. It's going to have 0 in it, and it's going to have 50.604. But actually, it's not really going to have 0 in it. What does x equals 0 correspond to? 1975. So apparently we're getting information about in 1975. Enrollment in U.S. elementary and secondary schools was 50.604 millions, right? And millions of students. Million students. Okay. So in that year, in 1975, there were about 50 million students enrolled. Now, the next year, what happens to the 12th graders from the previous year? They graduate, so they're not going to be counted anymore. So is this next number going to be smaller? So we got new first graders that weren't counted in the 50 million, right? Folks who are now just ready to start elementary school, they're going to come in. So yes, we're losing our high school seniors, but we're gaining a new class of first graders or kindergarten. I don't know what technically elementary school starts at. And so we're going to get a new number. And so if we plug in x equals 1 into this thing, we'll get a new number that will represent how many students we had, millions of students we had in 1976. Is that all right? So this formula tells you at any year between 75 and 96, you can figure out exactly how many, well, roughly, how many students were enrolled in schools here in the US, okay? All right, this thing right here has what kind of a graph? It is a parabola, because even though there's scary decimals floating around, it is, when all is said and done, x squared. So it's a parabola. Is it happy or sad? It's happy. It's about school. What's not to be happy about? So does this happy parabola have a max or a min? Has a min, and that is the question that we are about to be asked. For this period of time, meaning from 75 to 96, when was the enrollment the lowest? As soon as I see that word lowest, I translate it. What are they really asking us to find? The vertex. Find the vertex. So all the problems today at their heart just say find the vertex, but it's your job to recognize what they're really saying. They could say find the maximum, find the minimum, find the greatest, find the smallest, find the lowest, find the highest for the rock, but all of these words really just mean find the vertex. Okay, so let's find it. We'll use our negative b over 2a formula. And again, I encourage you to put another letter in the front of this thing. It's not just negative b over 2a, it's what? X equals, that is the x for the vertex. So let's write it before we use the calculator to help us. So we do negative b, negative divided by 2a. Okay, it is possible to type this into your calculator in one shot and get the right answer. It is also possible and very easy to do that incorrectly. So let me show you the wrong way to do this. Okay, so here's the wrong way. Negative parentheses negative 1.162 divided by 2 parentheses 0.058. Looks good, right? This is not going to give me the right answer, even though it looks good, because the calculator knows the order of operations. And so the calculator is going to do what first? I see a division and I see a multiplication. What does it do first when it sees those two? Multiplication and division, where are they in terms of the PEMDAS? MD, is M before D? They're the same. Yeah, multiplication and division are the same in terms of this hierarchy, this priority. But it does it left to right when it sees both. So it's going to do the division first because that's the first thing it sees. It's going to take negative 1.162, divide it by 2. That's fine. But what I intended was for the 2 to get multiplied by the 0.058 and then divide by the whole thing. Instead, it's going to take the answer that it gets here and then multiply the entire thing by 0.058. I only want the 0.058 on the bottom. It's going to pull it up on the top. This is not the right answer. Yeah, so if you're really insistent and you want to type this in one shot, an extra set of parentheses, like Sam says, will work. This will give us the right answer. Grouping separately the two things in the bottom, which is my way of saying, hey, you better do these. Whoa. Saying you better do these two things first. This is the right answer. Safer than that, I would say, is to just do the bottom separately. 0.116. Write that down. 0.116. Upstairs, what am I going to write instead of that? Positive, right? It's silly to type in negative and then negative. So I would say that this is what we should be typing in. 1.162 divide 0.116. It's very easy to get this thing wrong when you type in the Vertex formula in one shot. Okay, so this is 10 and then just a little bit. It's just a hair over 10. So I'll say 10.02. That's around 10.02. Okay, the tougher part of this, that's the tougher part, isn't it? Because we need to plug this 10.02 where? Back in for the X. And so it's quite complicated to type it in because of all those decimals. We just have to be really careful when we type it. Yes, that's absolutely. Oh, so I'll show you how to not round it on the calculator, but when I write it down, it's going to be rounded. So here's what we're doing. We're typing in E equals. I'm going to write all that, but I need more space here. So let me write down here at the bottom. Okay, so I'm just going to copy that formula, but instead of those X's, I'm first going to just put parentheses. Okay, so that's just the E formula, parentheses instead of the X's. And then what goes in these parentheses? 10.02. Now you can type this thing in on one shot on your calculator and you can do it safely because the calculator will follow the order of operations left to right, no problem. There's no divisions to worry about separately grouping things. So I'm going to boldly type this thing in all in one shot. And let's see what we get here. All right, so we'll try to move this. I want to be able to see. Be there. So So I'm just going to type this in. That's what I'll do. All right, so we'll just type this thing in. So 0.058 times parentheses 10.02 squared minus 1.162 parentheses 10.02 plus 50.604. I think that looks good. Again, it's safe to type this all in one shot very carefully. 44.78 and change. I'm not saying it's easy to type in. There's a lot of places you can go wrong, but if you type it correctly, just all in one shot, you'll get this right answer. Here's a small little detail. It is possible to not round it. As Katrina says, 10.02 is rounded. So this answer is not the right answer because I typed in 10.02. Really probably should have written down some more decimal places there. So if you have one of these kind of nice fancy calculators, it is possible to grab the answer that it gave you before. So this was that's really what it was, right? And it wasn't 10.02, it was this. So what I can do is the following. I can type in 0.058. I'm typing in this green thing again. But then right here, instead of typing that thing in, there's a fancy button down here in the bottom. It says ANS, which stands for answer, which refers to the previous answer, which is currently this 10.017. So if I do second ANS, I can then get the most accurate answer my calculator is capable of delivering. Yeah, I'm not worried about this detail, but if you're going on in math and you're gonna have a fancy calculator, you should know how to use it. So, and then we'll keep typing minus 1.162 parentheses, and then what should I put? Is the answer again, second ans, and then plus 50.604. I don't know how much difference it's going to make. We got up here 44.78398. That's what we got as our rounded answer. Let's see how close the best answer is. 44.783982. That's where it changes. Up here we got a 3. Should have gotten a 2. Not that big a deal. You can see how far away it is. You know, it's a very small rounding error that happened, but yeah, it is millions. It would be some more. So 44 million there. Is it a couple hundred kids? Let's see. So these would be thousands. These would be individuals. I think we're off by like half a kid. Okay. Last thing for this problem right here. 10.02. That corresponds to a year. What was x equals 0? Was 1975. So we need to add 10 to that number. So it's really 1985. Right? Do we see that? 0 is 75. So add 10 to 0, and we better add 10 to 75. So then our sentence is down here. Enrollment was 44.8 million in 1985. What's the other key word in this sentence? Minimum. That word right there is worth at least a point in terms of that sentence. Lowest is good. Don't say Vertex. You're writing this for a non-mathematician to read it, so that's true. But I'm reading it as a non-math person. I want a sentence that's written in plain English. Well, where are you confused, Michelle?
How that translated to years. Where did I miss that?
Sure. So we didn't write that part down. Let's write it down here. So we know that x equals 0 is 1975. X equals 1 is 1976. X. Good. You got it. Okay, there is one more problem here about a fireworks shell. I would rather you guys started the homework in the last 10 minutes, so why don't you start the homework? It is on the next page. In context quadratic problems. And I will be collecting these on a separate sheet of paper, so see what you can do with your neighbors in the 8 or 9 minutes we have left.